Hi guys, it's John the Quant here. I'm in a new place temporarily. Not too long ago, I was in an interview with a fixed income firm, and I was asked to describe repurchase agreements. And I panicked. I couldn't think of anything, and that really exposed a gap for me. It's a gap that's not really in my knowledge base, but definitely in my ability to talk about these things. So that's what inspired this series, where we're going to talk about fixed income and how these things work, and we'll do some of the math behind them. Today's introduction, of course, is on repurchase agreements. So, what is a repurchase agreement? Imagine I have a bond, but what I really want is cash. Now, I could sell the bond, but I also want to have the bond later. So what I can do is sell the bond with the agreement that I will repurchase it later. And that's all a repurchase agreement is. They're usually done with government bonds, and they're often settled every single day. And mathematically, it's pretty much identical to a collateralized loan. From my perspective, the borrower's perspective, I'm getting a cash flow now, and I'm expected to pay it back later. From the lender's perspective, I'm giving out cash. I have that bond as collateral, and I am expecting to get paid later. Now, if the borrower doesn't come back and repay me, I always have that loan, which I could then sell and recoup at least some of my losses. Now, these are generally considered very low risk. It's typically government bonds, like I said, and they're very liquid, and they're often settled every day, so it's very short term as well. Let's jump over to the iPad and see if we can learn a bit more about how repos work. We're over on the iPad now, so let's start by making a cash flow timeline. Over here, we're going to call this the near time, and this is where we are going to sell the bond from the borrower's perspective. And way over here, we'll call this T sub B, and it is the date when the bond reaches maturity. Now, somewhere in between there is the far time, and this is when we promise to repurchase the bond. So at the near time, we're receiving a cash flow, which we'll call P sub N. At the far time, we have a cash outflow, which we will call P sub F. And we don't really care about the cash flows at bond maturity because the entirety of the repo agreement falls between the near time and the far time. Usually, the amount lent, this P sub N over here, would be less than the value of the bond at T sub N, and we'd call the difference the haircut. But for this introduction, we're going to assume that we can get the full value of the bond. So we're going to say P sub N is equal to the value of the bond at time N. And how do loans work? Well, you get money now, but you pay it back later with interest. So over here, we can say that P sub F is equal to the value of the bond at time N times 1 plus R, where R is the repo rate. And that's the agreed upon interest that's written into the terms of the agreement. We're just going to assume that we have the exact rate for the length of time covered by the agreement. So from the borrower's perspective, we know what the cash flows are going to be. We know that we're going to get an inflow of V sub N at time T sub N, and we know that we're going to have an outflow of V sub N times 1 plus R at T sub F. And we could go deeper into this by considering what happens if the lender sells our bond before the repurchase date, but we're not going to do that right now. Instead, we are going to talk about the lender's perspective. So from the lender's perspective, we have a cash outflow of negative V sub N at T sub N. And the cash flow at T sub F, we actually don't know. We don't know if the borrower is going to fulfill his part of the agreement. And we could call that default risk or counterparty risk, but however you want to define it, it is the main source of risk from the lender's perspective. So let's say we, the lender, enter into so many of these repurchase agreements that we can use the expected value to approximate cash flows. And let's also say that alpha is the probability that the repurchaser repurchases the bond. So then our expected cash flow at the far time would be alpha times the agreed upon v sub n times 1 plus r plus 1 minus alpha v sub f. And v sub f is the value of the bond at the far time. That's how much we could sell the bond for on the open market. And we want to make money, right? We really want to make more than the risk-free rate, but for now we're going to assume that the risk-free rate is 0. So we need our expected cash flow at t sub f to be greater than the known cash flow at t sub n. So we'll need this one, alpha times v sub n 1 plus r plus 1 minus alpha v sub f to be greater than the value of the bond at time n. Now let's see what rate we would need in order to expect this to be profitable. First thing I want to do is I want to redefine this value on the far date. So we know that we started with the value on the near date, so we can actually rewrite this as v sub n plus some change, which I'm just going to call delta there. So if we can rewrite that, I wrote those out of order, but it's okay. Has to be greater than v sub n. Now I can divide everything by v sub n, yeah? Now here, v sub n over v sub n is 1, and here we have delta over v sub n. Now this delta over v sub n, that's the change divided by the original value, so I'm going to call this the percent change. I'm trying to get r by itself, right? So let's move this part to the other side. I'm sorry guys, I don't want to have done that. Instead, let's multiply everything out. Foil this thing, we'll get 1 minus alpha plus the percent change minus alpha times that percent change. And here we've got plus and minus alpha, it's going to cancel out. And I'm going to move things with alpha in them to be close together. Going to factor alpha out of that. Now we'll move that to the other side. Here we've got a couple of 1s that cancel out. Go ahead and divide by alpha. Move this to the other side as well to get that r is greater than the percent change minus the percent change over alpha, which we can rewrite as, well, alpha times the percent change minus percent change over alpha. Rewrite one more time as percent change times alpha minus 1 over alpha. Now that we've got this inequality set up, let's see what else we can figure out. We know that alpha is a probability, so alpha is greater than 0 and less than 1. Alpha is greater than 0. Alpha minus 1 is less than 0. So alpha minus 1 over alpha must be less than 0. So let's see what happens if the value of the bond goes up. The bond is more valuable at the far time than at the near time. Well, in that case, the percent change must be greater than 0. So when we multiply that all out, the percent change times alpha minus 1 over alpha, we are multiplying a positive by a negative, which gives us a negative number. So since all we need is for r to be greater than the percent change times alpha minus 1 over alpha, any rate that is greater than 0 will get us there. Let's see what happens when the value of the bond stays the same. Well, in that case, the percent change is 0. So whatever we multiply it by, we're still going to get 0. So again, any r greater than 0 will fulfill our purposes here. Now let's look at what happens when the value of the bond goes down. Well, in this case, the percent change is negative. So when we multiply it all out, we've got a negative times a negative, which is a positive number. So here, there's really not a whole lot we can say. We need our repo rate to be greater than the change in the value of the bond times alpha minus 1 over alpha. And I really think that's as far as we can get. We could use some maybe machine learning or other advanced techniques to predict the change in the value of the bond, but we can't really go any farther just by using algebra. So if the percent change in the value of the bond is greater than or equal to 0, we just need a rate greater than 0. And if the value of the bond is less than 0, well, then we need more information here. And that's it. I'm not going to record an outro back on the computer, but let me know in the comments, did I do this right, frankly? Did I mess up somewhere? Do you have a better idea? Do you have an idea of how we could keep going? If you learned something, please like the video. If you want to learn more, go ahead and subscribe, and have a great day, guys. Thanks.